Good afternoon or good morning, depending on where you are. My name is Professor Duke Orata. We are continuing with our thermodynamics lectures. Today we want to try to marry the theory of internal combustion engines. We have looked at the Otto cycle and we have looked at the diesel cycle. We want to marry it with some discussions on actual real engine issues, real engines, so that we have an idea basically what you really have on the ground. What you have on the ground. It's important to interface theory and practice so that the theory doesn't lag behind practice and practice doesn't lag behind theory. So we want to interface. So we want to basically interface theory and practice in internal combustion engines. From the onset, I will talk in terms of, we'll concentrate on what we call the cylinder head and the engine block. We'll not concentrate on the fuel system, we'll not concentrate on the fuel system or on the ignition systems. Because remember, we have talked of the internal combustion engine, we have said there's the spark ignition engine and there's the compression engine. Spark ignition engine and the compression ignition engine. And we say this more were gasoline engines, and this is diesel engines. So basically, when we talk of the spark ignition engine, we have the spark plugs, which ignites the compressed mixture. And in the diesel engine, we have the compressed mixture, which when we inject the fuel, in that compressed air, which is the temperature is pretty high, there is ignition. So we don't want to focus on the ignition systems, so we just want to focus on what is general to both the spark ignition engine and to the compression ignition engine. So I will talk in terms of schematics. I will not draw scaled diagrams. We just talk about schematics and have an idea what we are talking about. So let us divide our unit. Let's divide our unit into sections. So that this our engine, this our internal combustion engine, notwithstanding whether it's spark ignition engine or compression engine, are some very common components. So we can build it as a block. So we say we have the cylinder head. And then here, it's very important for us to put that mark. Then here, we have a very important item here called the cylinder head gasket. And then in our block, final representation here, we have what we call our engine block. And down here, we have what we call the sump. Let's just draw it a small box. That's the oil sump. Now, this is basically a container for the oil. And then in this cylinder head, you have the cylinder gasket, you have the engine block, you have the oil sump at the bottom. And so depending on where we are, if we are looking at the engine from the front, then if you go inside the back there, let's put a block here. we have what's called the bellows. The bellows, and the bellows as the units. Here is where we have the bellows. We have our gearbox. And we are keen about that. Why are we keen about that? From this bellows will be connected to the crankshaft. There's a shaft here, which will get into the engine block. And the bellows, we will have the clutch plate, and we'll also have clutch pressure plate. Clutch pressure plate. And inside here we have the release bearing. So think of it, this is towards the back of our engine. So we have our engine here. We have our engine here. So we will have a link between the bell house, where we have the gearbox and the transmission systems, and whatever is happening in the engine block here from the crankshaft and everything will be transmitted through the system, and of course the appropriate torque will lead to those rotational motions, which will lead to transmission, and then the vehicular motion. So just have this in mind. Let's just have this in mind. Also, just have this in mind. Let's call it A. Let's call this B. Now, so this is at the behind. So we are at the front of our engine. Now, we have talked about this piston cylinder model for both the Otto cycle and the diesel cycle. We talked of 4-stroke systems. We are not talking about the 1K engine, which is 2-stroke. We are concentrating on the 4-stroke engine. Let me just write here 4-stroke. So we won't look at the 2-stroke engine. Don't look at the 2-stroke engine because 2-stroke engine has no mechanical valves and so forth. So we don't want to go that direction. We don't want to go that direction. So we want to look at the 4-stroke engine and look at the generalized aspects of it, which is common to both the spark ignition engine and the compression ignition engine. What we have put there, the rear there, that unit there, is in all systems. Is all systems, in fact, is the link in all the transmissions which we have. Now, cylinder head. First of all, the cylinder head here, we have a top cover. We have what we call a top cover. We have a top cover. And it is through this top cover here, that's where you pour in your oil. Pour in your oil, because oil is a very important material in terms of lubrication. If your system is not lubricated, then even the bearings which facilitate rotary motion are basically going to be destroyed. And even if your pistons in the cylinder, remember we have our piston cylinder, we have our cylinder. Don't forget, just to remind you, then we have our piston. We have our piston. That's a piston cap. We have our piston pin. Then we had our rod. Remember, we have our rod. That's rotary motion. And this is reciprocating motion. Don't forget that. Then, of course, we have our units here, where we have our valves. And of course, we have the ignition unit. Let's call it ignition unit, whether spark plug or compression. And then we have our inlet valve. We have our outlet valve. Remember? Then we have our TDC. Of dead center, we can have our BDC here. And of course, we have the clearance volume there. So we have already talked of the piston. Depending on the stroke we are talking about, we have the inlet of the suction, we have the compression, we have the power stroke, and of course the exhaust. So we have spoken about that. Now, let us look at what is common to both systems so that we are able to marry what we have learned in theory in those lectures. We've talked about auto and diesel cycle, and just have a feel. We will not really have it exactly as it is if you are seeing the equipment, but you give you a feel of the thing, because it's very important that your theory matches practice. Your theory matches practice. It is very important that your theory matches practice. It's not a question of theory lagging behind practice or practice lagging behind theory. They need to be interfaced and resonate with one another. Well, now, so we have the top cover. So this top cover is where you normally put in your oil. In the cylinder head here, let us discuss them one by one. Let's call it Roman numeral 1, let's call that Roman numeral 2, and let's call that Roman numeral 3, and Roman numeral 4. Now, so when we focus on one, now you are familiar with that particular system. Just reminding you, please, if you have not gone through our discussions on auto and diesel cycles, please try and also look at the efficiencies of those systems. Now, if we look at the cylinder head, then we call Roman numeral 1, cylinder head. In the cylinder head, we have the camshaft. And this camshaft, you can just represent it schematically in that manner. And think of it like it has some stepping wheels. We step on the valves. And there has to be a very important thing called the clearance for the valves. And so when you are doing that, you are looking at the clearance, and so you have to use a filler gauge, what's called a filler gauge, to deal with the tappet clearance. Let's call these tappets. Tappet clearance. You have to do what is called tappet clearance. So this filler gauge is just like a Swiss knife. If you look at the Swiss knife had several knives in it. It has several knives in it. In the same way, the filler gauge has these metals which are of different thicknesses. That's a filler gauge, has these metals of different thicknesses. And so each engine or machine has a specific tappet clearance. So you use the filler gauge to adjust the clearance for those tappets so that they step properly on the valve and do the appropriate opening of the valves as is required. So that is the cylinder head. So in the cylinder head, we have the camshaft, and of course, you are able to, the valves are in that particular system, so that if you look at the valves, let me use this portion. So if you are to turn the cylinder head and put it vertically, if you are to stand the cylinder head and put it vertically, then you are going to see the combustion chambers for those particular pistons. You're going to see the combustion chambers. And of course, you will see the edge of the spark plugs. You're going to see the edge of the spark plugs. It's not very accurate, but it gives you a feel. Let's call those tip of spark plug. And these are corresponding to the pistons. So these are corresponding to the pistons, to the cylinder, piston cylinder. They are corresponding to the piston cylinder. And so also you are going to see the valve ends. Not very accurate, but you see the valve end. You not see the stick. So these valves are on the cylinder head. And in most cases, when, for example, when the engine has been run for quite some time, so that it is due for what's called overhaul, so that you replace the worn out components, it's called, you are rebuilding the engine, then you'll find that the valves, you'll find some shooty, they are quite shooty. They are quite shooty. So you need to grind them. And to grind them, there is a paste which you use, which you smear on your valve. Remember, your valve. Let me see. Let me try to do it as best as I can. And these are grids where you put the valve lock to lock it. And then, of course, there's the spring. When it's mounted on cylinder head. And so it is at the bottom here. That's normally sooty, so we do the grinding using a paste. And of course, you want to do it on it sitting on the cylinder head, on it sitting on the cylinder, so that it's perfectly fit and there's no leakage. In fact, sometimes you test it by pouring a liquid to see if it actually goes through. So that it should be held, there should be absolutely no leakage, it should be perfectly fitting. Of course, remember the idealized assumption in terms of piston we talked of, it should be perfectly fitting, rigid, frictionless, and massless. Of course, some of those elements, frictionless and massless, are not practical, but that's just totally ideal, but should be perfectly fitting. So even the valve should sit properly. So that if otherwise you do a valve sheet, you put a new valve sheet for it so that it's able to sit and fit. Otherwise, if you grind it and it sits well, you put in liquid, it doesn't go through completely. That means it's completely tight, perfectly fitting. Bingo, you are through. Now, so that's cylinder head. So we have seen the camshaft, the tappets, which you have to do tappet clearance. We have the valves. If you are rebuilding your engine, then you have to grind the valve using a paste. It has both coarse and fine pastes, so that you get it perfectly neat. Then of course you wipe it with one of the, you can wipe it with one of the gasolines to clean the thing so that it's perfectly fitting. And of course, when it's mounted, there is that lock ends, there are locks for it, and there's a spring there. We're fixing it is quite also a bit of work, quite a bit of work. So that gives us our cylinder head. So we have an idea what this cylinder head is. Now, let us forget about this back systems here, so that we use this portion here. Now, the cylinder head, once you are sorted with the cylinder head, you have the engine block. The engine block, of course, if you look at it from the top view, when you look at it, when it's down there, what you are going to see also is a pattern. You're going to see engine block has the piston cylinders. Top view. You're going to see the piston cylinders. This is where you put in your piston cap. You put in your piston cap. Let us use this portion here. So now we are in 2. Engine block. You have your piston cap. So you have your piston cap. It looks something like this. It's placed for the pin. The pin. That's the piston cap. Let's not put anything as yet. Piston cap. And we can put the pin. That's the piston pin. Now, there are some of those cups which, if you look, you'll see grooves there. There are some of them which have some grooves that has to do with the turbulence in terms of trying to get effective mixing. So there are all type of designs. They vary with different machines, but you see some form of grooves there. Some of them have signs to indicate to you which particular piston should be put in which particular hole in the engine block, showing you in terms of the firing and so forth. But most of them have grooves, and so if you have these grooves are mostly to facilitate turbulence, to enable fine mixing, complete mixing. So not all have. Some are just smooth surfaces, but some are grooved, so that facilitates in terms of turbulence, which assists in terms of mixing. So you have your piston cap here. Now, on this pin here, it holds the piston rod. So the piston rod, you can draw the piston rod in this manner here, the piston rod. You have the piston rod. Let me try to draw it as well as I can. Trying to do it as best as I can. Now, that's the piston rod. And the piston rod here, at this end here, to facilitate the rotary motion, we have a bearing. And also here, we will have a bearing. And remember, this end here is the one which is connected. This is which is connected to the crankshaft. Connected to the crankshaft. So you have this piston rod. So when you bring it in the cup, when you put it inside the cup here, that pin will go through that hole. And there's a bearing, and there's a bearing there, and that's where it will connect to the crankshaft. And so in this engine block, we have the holes where we have the piston. That's the piston cylinder. The piston cylinder. So this cap here, when it is completely now seated, we will now redraw it. So we have seen the block. We have the shape here. Of course, if you look at the block, you're going to see holes here. You're going to see all manner of holes, very symmetrical. And so, on top of this block here, that is where you put, it doesn't go outside, suppose it fits perfectly. This is just for illustration. That's just for illustration purposes. The shaded one, which I'm putting there. That corresponds to the cylinder head gasket. It matches the symmetry of the top of the block. But I've just put it like that so that you know what it is. The cylinder head gasket. We should fit that. There will be holes matching these cylinder holes, the cylinder itself. There will be holes on the cylinder head gasket matching those holes and each and every opening here. Because remember, all those openings have to do with the flow of coolant and oil. So those openings there, remember, those openings have to do with the flow of coolant and oil in the system. And that must be in the engine. The flows must be perfect in the engine. The flow of oil must be perfect. The flow of coolant must be perfect. So there are perforations in this engine block, having those channels through which these particular liquids flow. Now, if, for example, your cylinder head gasket gets overheated and is destroyed, then one of the things which you will see, normally if you look at your cooling system, you will see taints of oil in your cooling system. You see there's a mixture of, if you're cooling fluid is liquid water, for example, you're going to see, if you look at what's called the radiator, this is also one of the cooling systems, which is one of the cooling systems, the radiator. A radiator which is connected. Let us say we have the radiator. Let's just put it here. Say we have a radiator here. A radiator. There's fins. And of course the coolant is there. We have the, you can pour in there. Then you have huge hose pipes which connect it to the engine block. Normally they are rubber hose pipes cooling. So if you look at this radiator, if there's a problem with your cylinder head gasket, then of course you'll see oil mixed up there, and of course there'll be overheating in your system because gases are getting in, everything is not working right. So your engine will completely overheat. And of course, because most of these systems are regulated, they will definitely, the system will stall. It will definitely stall. You'll definitely stall. So you know this overheating. And of course, when that happens, that's why when you're opening this radiator, you have to be extremely careful because the temperatures are pretty high. So if you open it, you can sputter completely, extremely. Water's at very, very high temperatures. And that can be very dangerous, very dangerous. That's why when somebody's opening it, go to the first level to release pressure. You'll see it releasing a lot of pressure until it stabilizes. Sometimes, depending if it's metallic and so forth, somebody can cool it by pouring some coolant at low temperature, water mostly preferred, so that you cool down before you open it. But you will see that there's mixing of oil and water. Now, the heart of our piston, internal combustion engine, the piston cylinder system. So once we're in that system, we basically have the piston in the cylinder. And of course, to put that piston in the cylinder, we use a ring squeezer. A ring squeezer, so that you're able to squeeze. A ring squeezer is something which fits that cylinder piston cup. And of course, you have your units here. That's a ring squeezer. You squeeze your piston cup with the rings. Remember, the piston cup has rings. Normally there is compression ring, there is oil ring, and so forth. So you cannot just fit them in the block because they're a little bit. The diameter is a little bit bigger than the diameter of the cylinder So it has to be squeezed, so that if you try to squeeze it with all manner of things, you'll find that you end up breaking. For example, you can break some of those rings, and that would be expensive. That would not be a very good idea. So if you have a ring squeezer, then you just squeeze them and put them on top of the cylinder there, and then just tap it down with something which will not destroy your piston cap, so that it goes through. That's very, very important. These are very important. So once inside there, remember we have already said we have the piston rod, and of course that is connected. We have already shown where that's the one where it's connected to the crankshaft. Now, that crankshaft is a very important unit, Let's just draw a little bit what the crankshaft looks like. Not very accurate, but to give you an idea. So to give you an idea what the crankshaft looks like. So let's just draw something which looks like. I need to be a little bit more economical in my use of space. So let's just say that we have the rod. It's not accurate. The pistons. Not very accurate. So these are the piston cup, piston, you have the rod, piston, piston rod. So, as the piston moves up the cylinder, up, down, that is reciprocating motion. What we have here is that as this one moves up in that direction, these ones are moving in the opposite direction. So that reciprocating motion is now converted into a rotary motion through the crankshaft. So we have links in the crankshaft. As I say, we have links. It's not best illustrated, but think of this as your crankshaft. Think of that as your crankshaft. And so you have the rotary motion, so that at the edges there, you now have rotary motion. You have rotary motion. Very important. That whatever has been converted now, you have that reciprocating motion now becomes rotary motion. Of course, it is connected, like we said, in the bell house, there's a shaft there where we will have all these connections take place to the gearbox, and there's a so-called transmission unit, and the movements, the transmission movements, depending on the appropriate torque, will take place. So that movement is very, very important, and the pistons move up and down, up and down, up and down. The other important thing is, in terms of the ignition components,